So let's combine a few things together. So we're going to simplify each expression, assume that no variable equals 0. And the reason they do that is because you can't have 0 on the bottom of a fraction. So that's not overly important, but to mathematicians it is. So we have 2a negative to the negative 2 power times 3a to the third b to the second times c to the negative 2 power. We're just going to multiply the numbers together. So we have two whole numbers. We have a 2 and a 3. So 2 times 3 is 6. Notice I did not add those together because they are not exponents. And then I have a to the negative 2 power right here and a to the third power right here. And since we're multiplying these terms together, we're going to add the exponents. Negative 2 plus 3 is positive 1. So that would be a to the first power. And I don't need that first power there, so I'll just take it away. Take it away. There it goes. And that still means a to the first power. And then I've got my b's. Well, there's only one b term in there, b to the second power, so I'll just bring it over. And the same with c's. There's only one c term in there, so that's c to the negative 2 power. But I got a problem here. My problem is I should not leave a negative exponent in my answer. So I'm going to move that c to the negative 2 power to the bottom of a fraction and make it positive. So that's the final answer, 6ab squared over c squared. Part B is all division, so we're just going to subtract the exponents. So q to the second divided by q to the seventh would be 2 minus 7, and that's q to the negative 5th. R to the fourth divided by r to the third, we're going to subtract 4 minus 3, which would be r to the first, or just r. And again, do not leave a negative exponent in your answer. So I'm going to take that q to the negative 5 to the bottom, make it q to the positive 5. So the final answer is r over q to the 5th. And then finally, part C is we have negative 2a to the fourth over b to the second, all to the third power. So every number, every exponent will be affected by the third power. Negative 2 to the third power. So that is negative 2 times itself 3 times. So that means negative 2 times negative 2 times negative 2. The first two negative 2's multiply to be positive 4, but then when you multiply that times negative 2, you get negative 8. So negative 2 to the third power is negative 8. So I did not just take 2 times 3 and say that's my answer. It's negative 2 times itself 3 times. A to what power? So we do have a 4 and a 3, and they're both sharing the a, so that's why we multiply the exponents, so that's a to the 12th power, all over b squared. And this is done. It is tempting to take that negative 8 and try to move it to the bottom of the fraction because you see a negative number there, and I keep talking about moving negative exponents to the bottom of a fraction. But that is not a negative exponent. That is a negative integer. It is not an exponent, so it doesn't follow the exponent rules about moving things from the top to the bottom. So that's the answer. Now that we know a little bit more about exponents, we can use those in addition, subtraction, and multiplying of polynomials. When you're adding or subtracting polynomials, you're just trying to combine like terms. Remember, with the subtraction of an entire polynomial, a entire number in parentheses, we can change the minus to a plus and change this to an addition problem by changing minus to a plus and then changing the sign of every term inside this set of parentheses. So we would have negative 2x squared, change that plus 3x to minus 3x, and then change the minus 1 to a plus 1. And then we just add our like terms. So 4x squared plus negative 2x squared would be 2x squared. Negative 5x plus negative 3x, I changed that to a negative 3x, that will be negative 8x. And 6 plus positive 1 is 7. And that's all the like terms I have. I do not try to combine an x squared to an x with addition or subtraction. They're not like terms. They have to have the same variables. This one's already addition, part B is, so we can just jump right into combining like terms. There's no signs to change. So 6x squared plus negative 4x squared would be 2x squared. Negative 7x and positive 9x would be positive 2x. And 8 plus negative 5 would be positive 3. So 2x squared plus 2x plus 3. We can also multiply using the distributive property. So find 3x times the quantity 2x squared minus 4x plus 6. So 3x times 2x squared, I would multiply the numbers, but add the exponents. So 3 times 2 is 6, and then x times x squared is x to the third power. Again, we got that hidden 1 there with the x. 3x times negative 4x is going to be negative 12x squared, and negative 3x times 6 will be positive 18x. Finally, we can multiply polynomials by doing a multiple distributive property. This is why I don't particularly like calling it the FOIL method, because FOIL stands for first, outside, inside, last. So if you try the FOIL method and you try to do the first terms and then the outside terms and then the inside terms and the last term, notice the 4n gets left out. So that's why the FOIL method doesn't particularly work well when you have 3 terms inside a set of parentheses. So that's why I don't like using that particular method. But it's still just a very large distributive property. So we're going to take n squared times both things inside of parentheses. So that would be n to the third power. And n squared times 2 is 2n squared. And then we're going to take 4n times both things inside parentheses in the second set. So 4n times n is 4n squared. And 4n times 2 is 8n. And then finally, we'll take the last term times everything in the second set of parentheses. So negative 6 times n is negative 6n. And negative 6 times 2 is negative 12. And then finally, combine any like terms through addition and subtraction. Try to do this in descending order of exponents. That's going to be important later on when we get to division, which is not today, but it's coming up. So there is no other like term to n to the third power. We do have like terms 2n squared and 4n squared, so that adds up to be 6n squared. 8n and negative 6n are like terms, so that adds up to be positive 2n, and then negative 12 has no like terms, so I'll just bring it down. So there's your final answer when you multiply polynomials.